In example 18.5, I want to continue to build our library of parent functions. We're going to look here at the picture of an exponential decay function. We're asked to graph g. G is defined over the domain of all real numbers by the equation g of x equals 1/2 raised to the x. So that base value of 1/2 is what indicates that we're looking at something that's a decay model. And I'm going to take the same approach that we did with example 18.4, which is to make a table. Using the same values for x, -3 through +3 integers. I'm going to start with 1. 1/2 raised to the first will just be 1/2. 1/2 raised to the second will be 1/4. 1/2 raised to the third is going to end up being 1/8. 0 as an input, we know that anytime we use 0 as the exponent, the result is just going to be 1. And then we also saw that the negative exponents are expecting to give us the reciprocal of whatever the positive input counterpart was. So with 1/2 raised to the -1, I'm going to end up with +2. 1/2 raised to the -2 will be +4. And then 1/2 raised to the -3 is going to be +8. Very similar values that we had with exponential growth, but we're going to see that they end up going in different places on our Cartesian coordinate plane. So let me start with -3, 8, -2, 4, -2, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and then 3, 1/8. We still have a nice curvature here, nice smooth picture that we can draw, but instead of increasing, I can see that we are decreasing. As I go further out to the right, I'm going to be flattening out, getting closer and closer to the x-axis. So there is a horizontal asymptote here, just like there was on exponential growth. And now going to the left, I'll be going toward positive infinity as I go to the left, continuing in the decreasing trend as I look at this from left to right. This is the graph of g. This is my go-to picture for exponential decay. The domain of g was given to us by the function definition as all real numbers. The range of g will be from 0 to infinity, and the only asymptote is that horizontal asymptote located at y equals 0.